Yeah. I hope it is recording too, right?
Yeah, it's recording.
Okay, thank you. So the first problem is problem number 893. It's an easy problem. It says about groups of special equivalent strings. Here we are given a array of strings, and these strings are all special equivalent strings. So we need to group each of these strings into a special equivalent strings group and then return the number of groups. So what do they mean by special equivalent strings? There are some examples they have given. So one of the example what they have, you know, explicitly stated in the problem statement is something like this. If we have, oh, sorry, I just copied the wrong one. So if S is something like ZZXY, and we have another one which is T, which is also XYZZ. So these both are special equivalent. So when they say special equivalent means that when we swap two of the letters, either the odd or the even ones, and when they are equal, so if I swap X with Z in T and then make it something like Z and then X, right? And similarly for Y and Z, so make Z and Y. So now both of them are same, right? So that is what they mean by special equivalent strings. So we just need to find out all these special equivalent strings in our input array and then group them, and we return the number of groups. So we have this example over here, and this example actually we can divide in two groups. Okay, so this can be divided two groups like I think these two, one will be ABCD and other will be CDAB. Okay, so the way it can be done is C can be actually swapped with A here and D can be swapped with B, so it becomes exactly like the first one, ABCD. Same thing for the third also. If we swap C with A, it becomes A will come here in the first position and C will go in the third position. And the same thing will be for B and D. So these three will form one group. Okay. And if you look for this one, they are, anyway, the letters are also different between both of these two groups. And then if we swap all of them one by one, the way we did for the above group, we can get another group, which will be second group. Okay. So we just need to return the number of groups. Okay, and if we take for the third example here, so
the first example say there's three group. The output is three.
I'm sorry, my bad. Okay, yeah. So maybe we'll have to go through that then. One is A, B, C, D, right? So other will be okay. Oh yeah, this is the first group, right? And the second group will be like we can make this they both same, right? But not this one. Okay, my bad. Thanks, Leon, actually bringing this back. So this is our second group, and I think we don't have anyone in the third group, right? It's a single string. So that is the third one. So in this example, I think we have this ABC, this one as one, and then we have this CBA, right? So these two can form one group. And then we have this ACB here, okay, and then I think, okay, ABC, B is the middle one, so we can actually swap only A and C, so make it CA, this is one, and for ACB, I think BCA, right? So if we just swap AB, we can get BCA, and for BAC, we can swap B to C, and then it will be CAB, right? So here also we have three groups, correct? Okay. So the constants, what the nodes, whatever they have said, it's the length of the whole input will be just 1000, and maybe from 1 to 1000, and then the length of each and every element of that input array will be 20. So it's not a big length though. And then all of the lengths of each and every element are going to be the same, and everything is going to be lowercase. So yeah, so that is what the whole problem statement is. It's pretty lengthy. Okay, so any questions on the problem statement? It's an easy problem, right?
So here we can swap only the even or odd indexes. Like you can swap with between even indexes or odd indexes. That's a main constraint here, right?
Yeah, yeah.
Okay.
So we cannot swap cross like one even and one odd and one odd and even. So it has to be just evens or just odds. But we can have evens anywhere. Like we can have the second swap with the eighth also. That should be fine.
Yeah. Yeah.
Yeah.
If it was everywhere, then it is like it's like a anagram problem, right?
Yeah. Yeah. Right. So this is also similar to an anagram problem, right?
Yeah,
To
but
some
here,
extent.
yeah, maybe I did not solve. I was just thinking it since it's anagram, only constraint is you can do it even and odd.
Uh-huh.
Maybe take from the input, just take the even characters and the odd characters,
Uh-huh.
and maybe traverse and just check like, if those even characters exist, then maybe group it. I don't know. I mean, just like a vague idea.
Oh no, no, that's good. Yeah. So when you said about anagram, I was also not thinking that way. But when you said anagram, I said, yeah, that makes more sense now. In fact, yeah, that's good. So you said we just group all these even and the odd separately, something like that, right? And then
Yeah.
traverse for the similar ones.
Yes.
Same strings, yeah. Mhm. Yeah, it's an easy problem, so I think that should make sense. And
Yeah, it's easy, but it's not easy to
understand.
see that as it is an anagram problem, because the way they talk, like you can swap any number of times,
Hmm.
right? You put on the even, the odd, and because eventually, because you can swap any number of times, then you can make it like an anagram. Yeah.
Mm. Yeah.
And I found that the question is a bit difficult to understand for me.
Yeah, that is true. We and also the description is big, so we need to go through it at least a couple of times for sure. Because just swapping it and what to do, but actually it is like that, I think. Just swapping it and then finding. But then we start thinking about it in the terms of complexities, right? The time complexities and all that, whether it is really good or not, and then what data structures and what algos and everything. So, but I think it is what exactly it is, what they have described in the problem statement. Yeah. But as you said, Leon, that's correct. It's not an easy also, looks like. Yeah. So any approach, anyone want to discuss about it?
I have a question.
Uh-huh.
Uh, can we sort each element in the given list?
Each element in the input string, input array.
Yeah.
Um, you mean to say individual array or individual element or the whole array?
I mean, each individual array, string, given string.
Um, yeah, that's fine. Whatever we do, that's not an issue. So, okay, so what do you want to do? Like, if we take the example, the first one, right?
Mhm.
This one, okay.
If I can sort each string in the given list, I will loop through the whole array, given array, and first I will sort it and store it in some array or anything, and I will check if that's present in the the created array. I can increase a counter. I mean, a variable that counts like +1 or something.
The groups, right? Yeah. So are you saying like if you have A, B, C, D, right? Okay. For the
Mm-hmm.
C, A, B, D, you again want to sort it, so make it A, B, C, D, right?
Yeah.
Something like that.
Mm-hmm.
Yeah, that might work for the first statement, first problem example, but not for the second one, correct?
Yeah.
So second one also we have all the same letters, so we will find only single group in this. But if you look at the problem statement, sorry, the output, it says it is three groups, right?
Yeah.
So
So first, I mean, can we like? It will take a lot of like space. Sorry.
no, no problem. So what do you want to suggest?
Can we like first like the second problem ABC and ACD?
Hmm.
First, the counter we will like initiate like
Hmm.
um, I don't know how to explain this.
Okay.
Uh,
So counter,
um,
you are trying to say what counter? So okay, so the way I was also thinking, like go through each and every string, take first string, okay, and then start
okay.
comparing with others if all the letters are same, right?
Yeah. Yeah. Mm-hmm.
Yeah. So then every time you compare, okay, so I say, okay, now what is common in this example, the second example, right? So I just skip them. Like, okay, A is common here, A is common here. So I can't do anything,
Yeah.
right? Then go for
Mm-hmm.
B and C and C and B, but they are actually not evens and not odds, right? They are not same. So
Yeah.
it's different. So I just skip it. Go to the next one, right? So then
Mm-hmm.
you try to see if what is common here. And I think C is common here, right?
Yeah.
But then
Mm-hmm.
B and A actually are not on the same. So I go
Yeah.
here, something like that. But that is actually more, what you say, implementation details.
Mm-hmm.
So you are actually on the right path, I would say. So the way they are saying, what to do is you do sorting, but you do sorting only of odd letters and the even letters separately. You know.
I mean,
So.
first, like in second example,
Mm-hmm.
I'm sorting first element, okay,
Mm-hmm.
and I'm like saving it in another array,
Mm-hmm.
okay,
Mm-hmm.
and I will count like for second, I will initiate a counter like if the second element in the given array is present in the my created array,
Mm-hmm.
we will count one, okay,
Mm-hmm.
and it will go on and like count, okay,
Mm-hmm.
and if it's not present in the, we will add it and like and make our counter 0 so that the next like the ABC will have a counter, okay, we can store that in another array or
Mm-hmm.
something.
Mm-hmm.
And like uh, and like other string which are not similar to the like ABC, we
Mm-hmm.
will like store another counter, and then we will return the all count length of all the array like this
Okay.
counting. I don't know.
Right, right. So instead of storing it in another array, I would say like store it in a map or so, another map
Yeah,
if it's a C++.
dictionary will
Dictionary, yeah.
dict will, yeah.
Right, right. So you can just count the number of elements what you found with that.
Yeah,
Yeah,
then we will like loop through the dictionary and return the length.
right, right, right. So yeah, that should work. So if we take the example two, so we can say like first we have A, B, C. Okay. So this will
Okay.
be our first element. Okay.
Mm-hmm.
Right. So then we go with ACB. Okay. In ACB, what we do is we actually group the even and odd in this case, right? And then we sort them. So if we sort even and odd, it's going to be like, for this one, it will be something like, it will be A, and then if B is A and B, I'm taking both of these odd ones together, even ones together, and then C, right?
Yeah.
So that is one thing. But yeah, in this case also I'll have to again sort it that way also. So it will be A, C, and B. So this is A. So I'll just write on top of them so it will be clear. So this will be A, C, B. And then this guy will be A, B, C, because we have to sort only those two, right? The evens or odds. But here we only have evens, we don't have odds, right? So here this will be B, C, A, okay? And then in this case, this will be B, A, C, correct? And then this guy will be B, C, A, and this will be A, C, B, right? So now I can say like this ACB here and this ACB match.
Yeah.
So I can say
Won't the fourth one be ABC?
1, 2, 1, 2, 3, 4. Which one? This one?
Yeah.
Oh, yeah, it should be AB, right? Yeah. Thank you. A, B, C, and this is correct, right? B, C, A,
Yeah.
A, B, C, and B, C, A. Okay, thank you. So I can group them right now. A, B, C, this one, and then C, B, A. They can form a one group, correct?
Okay.
Yeah. So this is one group. Then
We can use dictionary, I guess. Like
Yeah,
while
yeah.
looping, we store that in a dictionary.
Right. So I'm just storing it in dictionary. So first
Yeah.
element of my dictionary here, and the second element is like A, C, B, right? So A, C, B, I just take this A, C, B here and then find A, B, C where I do, this is A, B, C, right? So I just say B, C, A, right? So this will be my second, and then the next one will be my third one, right? So third will be B, A, C, and I have this guy here. So this is the CAB, correct? So these are the two groups. Okay, sorry, three groups, and then I return the number of three. That's
Yeah.
three, right? So something similar like that. Yeah. So I think this is the right approach, and that is what I also found out after going through all the discussions. But there might be more optimized way of doing it, but
Yeah,
on a
it's
broad level,
taking
it
a
is
lot
like
of
that.
space.
Excuse me, sir.
Yeah.
Sir, I have one more approach. If I could discuss that.
Sure, sure.
Yes, sir.
Do
So
you want to share your screen?
no, sir. Actually, I'm a newcomer here, so I have been through these questions. I have just not seen them. So, sir, what we could do, like, for the given input, we can have two arrays. In one array, we can have uh, odd number elements in a sorted way of each of its elements. Okay, and in the other array, we will have a sorted form of even part of each elements in that array. And then what we could do, we could go through all the like with elements of like zeroth element, if the zeroth element is if it's equal to some other element in that group, like what we did pretty much here. We did the same. So if that's equal, we'll check the same in its even array. Like we would uh, throughout this process, we'll just check that if any two numbers, if any two or more than two, if they are equal to each other, then we'll check that whether the given thing is also equal in their respective even array positions. If they are equal, then they are in the same group, right?
Right. So if I understand correctly, the way you are saying, if I take this input, okay, so this input, if I take this one, you want me to actually divide this whole thing into first even and odd, two arrays,
Yeah,
correct?
we'll take two more array. Yeah, we will take two more array of the same size, and
Okay.
for each and every element.
Let us do it here,
Yes,
so this is one, and this is one even, okay, even, and this is odd. And so you just want to separate all of, so here even will be like, I just remove A from here.
B and D.
Yeah, B and D. In this case, I remove same, right? B and D again.
Yes, sir. Yes, sir.
And B and D. So this
And
will also.
we'll pretty much do this.
Right. So this guy B and D. Yeah. Okay, and for the second one, we just remove the first one, right? A and
Yes,
C,
sir.
and C and A. So C and A, and in this way we remove X, Z, and Z, Y, and then we remove C, Y, one and the same, right? Yeah.
Yes,
Okay.
sir. Yes, sir.
Uh-huh.
So yes, so sir, in the even array, if we take the even array like A, C, if we sort each element like AC in first zeroth element, it's AC. In first element it will be AC. In second
Okay.
element it will be AC.
Right. Yeah, and this guy will be right. This XZ. This will be XZ, and this will be YZ.
YZ.
Yeah.
This is awesome.
Yeah,
Yeah. Yeah.
and in the odd if we do the same, and then
B,
if we
BD, and then BD, and XZ, and XZ, and there's again XZ, right?
yes sir.
XZ. Okay. Let's
Yes,
check.
sir.
Okay.
So now if we go through the even element even array, so then we see that zeroth element, first element, and second element, all three are same, and
Right.
then we check the respective elements of the odd array. If they are also same, then we have a group.
Right. Right. Absolutely. So this becomes one group, correct? I'll just
Yes,
say
sir.
1 year.
Yes, sir.
Okay, and this also one. Okay, and then the second one will be XZ, XZ, XZ both. Y
Yes, sir.
won't be there, so this will be the second group. And then we have the second group, right?
Yes, sir.
Okay, and then the last will be the remaining one.
Sir. Yes, sir.
Okay, perfect. This works. Yeah.
Yes, sir.
So, but yeah, it's good, right? There's no space, and it's almost the same what you're going to use, because you're going to use anyway. You have to use the input array, right?
Yes, sir.
So no extra space that. Yeah, you can.
This is a very good one.
Yeah.
Reduces the. I mean, when the solution is evolving, it is actually making things simpler, better to understand. But actually, whoever was sharing this approach, if you could share what all things you thought of before coming up to that, your thought process, probably that will be awesome.
Actually, sir, I have joined this class for the first time, and just now I read this whole question, so it was pretty much impromptu at this time. At this point.
Wow, that's good.
Perfect.
That's really good. Well, actually, we just take 3 examples every. Means if they are posted the previous day at around this time, and then we work on it, and the next day we come and actually solve it together.
Yes, sir. A friend of mine who recommended this, so actually that's why, sir, it's helpful for me.
Yeah, no problem. Yeah.
So just one thing I want to point out. So after we came up with the even and odd arrays, the rest of the thing actually is following the what is that, anagram approach. So
yeah.
in
Right.
anagram,
Yes, sir.
all we do is basically create the signature, which is the sorted string, and we create a map. As many number of items are there in the map, the number of keys in the map are the end of the whole thing. So basically AC, 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 we threw it. We counted it 3 times, doesn't matter, only one key. Then XG, XG, that is also another key, key number 2. YG is another key, 3. Then BD, that is another key, so that is 4. Then, right? So
Yeah.
is that how we are? Oh, no, probably I misunderstood. We said AC and BD, they are number 1.
So they belong to a single group, right? We just have to return the number of groups.
Right. Then how can we implement that part? Actually, I'm taking my word back. I thought it is just straight away reusing the what's that, anagram algorithm.
It is correct. It's exactly the anagram. What he suggested, only breaking it into even and odd, And then we actually sorted them so we can compare them, right? So these are the anagrams of even and odd.
But how do we compute that AC and BD? They give us one anagram. I mean one group, whereas XG and YG they give us two groups.
So here is the second group, XG and XG. Here, unfortunately, unfortunately, both are same, even and odd.
Yeah, actually, if you could just change the last XG in the odd to 2, that would make things clearer. Yeah, last XG.
Oh,
where you have written 3, it should be 2.
No, this is a part of 3 because its YZ is different, right? So if the even part is different than the odd, therefore it belongs to a different group. So this YZ, its even part is different than this one, right? So this is a different group, but it's odd also, even if it's same with the previous odd, with the second group, they cannot be in the same group because its even part is different. So therefore it is grouped as a separate one. Because this is a single element. So if you see the grouping here, in this case, it is like these 3 are one group, correct? So this will be the first group. Right. Then these two are the second group. Okay. And the last one is the third group. So it's exactly what you are thinking. So and therefore you have, even though you have the XZ here of the third one, the third group is similar to the one of the odd of the second group, but its YZ, which is the even one, is different, and therefore it forms a different group.
Okay.
Yeah. So this is the first group, and then we can put in a dictionary, right? Or maybe an unordered map, and then this is the third group. That's correct.
I think I missed one thing. Sorry if it is taking more time. But
no problem.
What I'm saying is, yes, I understood how we computed even and odd at line number 25 and 26. But what I'm not sure is how did we identify the groups? If you could repeat that.
Okay, so identifying the group first, what's your name? Who actually suggested Gaurav? Okay, yeah. So we have many Gauravs today. Okay. So what is suggested, form an even one, right? So these are the even letters, correct? Which we are sorted.
Right.
Yes, sir.
Rajendra, yeah. And this is the odd ones for the same. They are all same. Therefore, they form a group, correct? So here, all AC are same, and all BD for the odd ones are same. So therefore, they form a one group, and therefore, hence, this is a single group, the first one. Okay. So now we go for XG and Y, this 2 1, right? So here, what happens? So the evens are XZs for this group, and odd are also XZs, correct? So how we get the evens and XZ, right? So I take this X and then this Z, correct? The same thing for Z here and then this X, correct? So YZ, Y here and YZ for the odd ones, and Z and Y. So therefore, these both form a same group. They are exactly the same here, right? So therefore, this becomes the second group. And the third group, we don't have any other element which we can compare. But if we take ZY, right? So here it becomes YZ, which is a very alone component. It doesn't match with anyone. And then we have ZX, which is the odd one. So we just sorted it, it became XZ. So therefore, it is in a different group.
It's more of like a coincidence that they have,
right.
And they have at the end they are same. It's just because of that. It's just a coincidence.
In the group number 2, why we don't see YG? Why don't we see YG? For example, XYGG, that is the first in the, so that one. So if we remove the evens, we get XG. That is clear. If we remove odds, we should get YG, right?
I think in this odd array, this XZ is wrong. It should be YZ. It will
sorry.
YZ.
Yes.
I am sorry. Yeah. Okay, that is what you are trying to say.
Yeah.
Okay, no problem. My
Yeah,
bad.
actually,
Yeah.
I was just figuring out how you made even and odd arrays because I got lost in the concept itself. Now I am like,
Okay.
now it is clear.
Yeah. Yeah, because Shashank is not here, so blame it on him. Okay. So YZ, I'm sorry about that. So XZ and YZ. So they form one group, right? So this is the second group, and in the third we have a separate one, correct? So Rajendra, this is clear now?
Yes. The only thing is,
and it's more of a, like, you could say that in this case it's made up of two anagrams. Both the anagrams are actually exclusive to each other. If we take the example of even and odd, in even you could shift, it's actually anagram. In even, all the elements are anagram in one group, and in the same group respective to it, they are anagrams to each other. But what we are basically doing, we are just combining at the end both of them. So it's, at the end, it comes out to be a single anagram. It's more of like that.
ABCD, ABCD, ABCD.
Yeah.
Okay.
And here, like, while comparing at line like odd and even, it's like n square, right? Because I mean, the example here, I mean, we have when we divided into even and odd, we have adjacent uh, elements are equal, but ideally, like, we may have to compare with every other element, right?
Yeah.
Or we have
At
to
least.
sort the entire even list or list maybe.
Yeah, there will be computations involved. Yeah, that is true. We'll have to go through each and every element and each and every letter first to form an even and odd index and then sort each and every individually. Yeah, but it can be more optimized, but overall it's a similar approach, I would say.
Yeah.
And that's the only approach I could think of. Means actually Gaurav came with that. So I don't think.
I want to understand a little more. So
Uh-huh.
when we were computing even and odd,
Mm-hmm.
did we assume that the input is already in the lexicographic order?
Not required, right?
Okay.
So we do it, and then when we are actually grouping it, I think Sandeep, right? Sandeep said no about grouping it. So when we sort them, then we actually put in some sort of an unordered set or maybe something like that, right? An unordered map also.
Yeah, actually, in the example, even and odd, while doing it, we sorted it. If you're confused on that part.
Yeah, when we did the example, we sorted it. So, but we'll have to actually every time make these even and odd separate and then sort them individually.
Yeah. Or
We'll have to do that.
if all the elements are, I mean, if the input is a lowercase, then maybe we can use an array to
Yeah,
optimize. Yeah.
either we use an array or we just sort it. Yeah, either of that. Array will you consume more space. Sorting will also be the same, right? We'll have some internal spaces.
So are we saying that after we compute the even and odd, and we sort each of the elements in, say, even, then we can just make a cluster of these things and we can simply announce we got the result?
Absolutely.
Without looking at odd also?
We'll have to take odd and even together and then maybe do something, right?
Take odd and even together and create the anagram kind of thing, then we are losing basically the second group and third group will look the same.
Okay, so if you see for what it will look like if I'm putting this in the C, if I combine AC and BD, okay, I'm not going to change now because I already sorted that. I made this group, right? So I have single element now in my, say, maybe an unordered set. So the second will be XZ and YZ, okay, and the third will be like YZ and XZ.
Yeah, maybe
So
you can just use a hatch set, right?
Right. If I just put in a set,
yeah.
so it will actually eliminate all my duplicates, right? So I will just have 3 elements here.
Okay. Somehow the amount of work involved, it doesn't look like easy then.
Amount of work involved is more, but
Like
yeah,
space is also more, I think, even, odd, set.
Yes.
yeah.
Yes.
So
Too
overall
much
it will be
space.
like this, but then we can optimize it, to some extent. But I don't think so we can optimize more in that. But yeah, if you have some other suggestions and some other approach, I think we can discuss that too.
No, I
But
don't.
now when you summarize it, it looks easy, right? Like take each word in an array and divide it, create 2 string builders, one with even, one with odd, sort it, join them and put it in a hash set.
Right.
Right? Yeah. At the end, you will get like, unique words.
Right. The unique one. And then just return the
Yeah.
number of it. Yeah.
Santosh, can you
Yeah.
please explain the approach which you explained above this?
Which one?
This ACB on line 15, line 12. Like above how you wrote that ACB, ABC.
Well, actually,
Line
you
11.
used his. It is the same thing, because only I'm just removing the even ones here, right? So even here is A and then C, correct? And then what I did is just A and C sorted, so made it the even I sorted first AC, and then just appended the odd, because odd in this case I have only single element, right? So I just have to append it. So this becomes almost the same problem what he has discussed here.
Okay, you sorted.
Yeah. So
Like you took. Okay.
if I take A, B over here, then I sort them first. So A, B here, right? Then
In a
the C here.
pen.
Yeah.
Okay.
So in this B, C, I just take it though. So this will be B, C, and then you append A to it because it's single one. And that is the way the whole group is formed. But actually, he made it very clear by explicitly taking both of them separately, and then actually, it's more easier to visualize also, right? So
Yeah.
if you want to actually break down a problem in an interview, this is the best way to do it. Okay. So, Gaurav, do you want to share your code if you have, or you want to write something quickly though?
No, sir. Right now, I just can't write this quickly.
No problem. No
I'm
problem.
quite a rookie.
Okay, no problem. I will just show my code, what I've written. Yeah, go ahead.
I think splitting the even and odd, that is not. I mean, the amount of work that is being done here, it is not suitable, especially the even and odd separating part, even and odd generation for each string. I think that is some bulk amount of code there.
It is, and that is true. But I would say being a very easy problem, so that might be slightly okay. But as I said, that it can be optimized more, and we can find out much better options also. So this is the almost similar way what I followed. Okay, and so I'm not sure whether it meets Gaurav's expectations though, but I'm just using an unordered set here, and then for each and every string, I'm just having 2 strings as odd and even part, and just collecting them here, even and odd, and then sorting it here. And then when I sort it, I just combine both of them. Sorry, I combine both of them and put in this set, right? So if I put it and then just return the size of that set, so it satisfies this output. Right. Yeah. But as Rajendra, you said, yeah, you will involve a lot of things because we are going to each and every, what do you say, letter of a array input, and then actually segregating them. And again, above that, we are sorting it. So again, we are internally consuming some memory also in the sort. But yeah, this is what it is. It's not a great in of time complexity per se of that lead code one, but it gets accepted.
Excuse me, sir.
Yeah.
Sir, one more thing, like in my approach, I have one fault which I would like to point out. Basically, like if we take that case, like what we were basically doing, we were just going through any of these array, like even or odd. What we were doing, we were basically counting after sorting each of the elements. What we were doing, we were basically checking how many of them are same to each other, like AC, AC, AC. For that, we are saying that zeroth element, first element, and second element, all three are same. And but if what if we take the case like in the last element, if the last element of even array had that been xy instead of yz, had that been xy, we would have gotten three elements xz of the same, which are same, and had we been comparing the same with the next in the odd, we wouldn't have been getting the same answer. So what we would have done, we would have rejected that answer. Basically, I hope you got my point. Like if we changed that last element of even array from yz to xz, xz, and if we check the number of same elements that are equal to xz, then it would have been three from even array.
That is fine, but even if we are comparing that way, we'll always compare its odd also, right? Then only we can group it.
Yes, sir. Yes, sir.
So then it still should work, right?
Yes.
In set,
yes,
it will
sir.
always go like A, C, B, D, and then it will go X, Z, Y, Z, and then it will
Yes,
go
sir.
X, Z, X, Z. Then it will be three only always. And I
Yes,
think
sir.
three would be the correct
If we
answer in that.
if we check both of them simultaneously, like at the same time, if we are when we are checking even elements, we have to check that odd elements also. We just can't go like these xz are same in even, and then we check its respective elements. We have to check the elements in the even and odd array at the same time while we are checking comparing with the other elements.
Right, that we have to do it, yeah.
Yes,
Or
sir,
else then it will be a lot of competition.
So to make it simple, what we are saying is we traverse both the arrays at the same time, just concatenate the elements at the ith position, and then we put that in our set. And at the end of the day, whatever is the cardinality of the set, that is the answer.
Right.
Yes, sir.
Exactly. Yeah, but the problem statement breaking was great, I would say, Gaurav, because I also didn't understand. I just went through this. I said, okay, this looks good, Yeah, but that's good.
Good visualization.
Yeah, absolutely. So, anyone wants to share any of his approach? Anything? You guys want to discuss anything more about this, or we just move on to the next one? Okay, so if it's silence, then I'll just move to the next one. Okay, so the next problem is bag of tokens. So this is also a very different problem. It's from the medium bucket. So usually the medium buckets are not so easy. And what it says, we are given first is a bag of tokens, right? Bag of tokens. And then we have given a second input. This is the first input, and the second input is initial power. Okay, so I'll just say power. So this is some value. And then what we need to do is we need to take each element in the bag of tokens one by one. And then it's a small thing. It's like a big game or so. And then we need to compare these bag of tokens will have some values. So we need to compare these values with the power what we have, So power is also some integer value. So if the token value is lesser than the power, we can actually use that. And they say we have two options. One is we can play the token face up, okay, And when they say token face up means, if you take an example here, if I have something like 100 as P, and then in this case, if we have token something like 25 and then 50, something like that. So if I take the first one as 25 is lesser than 100, I can play the first way, like the token face up. What it means is I can actually use that 25 and reduce it from my power, which is 100. I just reduce that to 75, right? But I gain 1 point. Okay, so the points is very important here. So I gain 1 point here. And the second way I could play is, the token face down. Okay. So when I say token face down, it means I can only play if I have a point, at least 1 point I have to have, but then I lose that point. So in that case, what I can do here, if I go for the second token now here, as I already have 1 point, so I can use that 1 point and then gain the power. So if I have power 50, I can lose 1 point, but I can gain 50 here, the same amount what I have in the token. So now my answer will be something like 125, but I will have 0 points. Okay, so this is what, and at the end we have to return the number of points. Okay, so this is what the problem statement is. But if you go through one by one all these examples, it might be slightly clear. So for the first example, if you look, the power is 50. Okay, and the bag of tokens, I have only 1 token here. Okay, and this is 100. Okay, so in this case, what happens if I'm not able to play? Actually, I should return 0, because the bag of tokens is 100 and the power is 50. So actually I can't satisfy the first condition. I can't play the token face up, right? Because I need to have the bag of tokens lesser than the power. So this is not the correct situation. And also I can't play the second one because I don't have any points, right? So therefore the output is 0 in this case. Now if we go for the second one, so we have given been 2 tokens, one is 100, 200, and my power is 150. So in this case, what we can do is we can play the first one, because this is 100, right? So my power is 150. So I can play that. I can gain 1 point. So the points gained will be 1. So, but I will be losing power here. Okay. So my power will be now 50. Correct. So for the second one, when I come in, okay, I can still play because I have a 0.1, right? So then what I will do is I will go here, and then 200 plus 50 will be 250. And then I will lose my point, right? So at the end, what is the maximum number of points I gained here is 1, right? So we just return the maximum number of points in the whole game I could win. So this is 1. So if I go for the third example, then actually things will be slightly more clear, I would say. So if I go 200, then we have 300, and then we have 400, and the power is 200. Okay. So in this, what I do is, if I start with from the 100, right? So if I go from the 100, I can play here, I gain 1 point here, and I reduce the power from 200 to 100, right? So then I go for 200. So my current power is 100. So actually I can't, gain a point, but I can gain power here. So the way I gain power is I lose my point over here, right? And then I gain from 200, which I'm having this 200. Then I add the remaining one, which I get 300, right? So, and then I can go for the second also. I can play that one because both are power and bag of token. The power in the bag of token is same. So I can just gain another 1 point, right? Right. And then I can lose so I'll be having 0, correct? And then I go for the last one, I can have 1 here, but at the end I'll be losing that power point, but gaining power as 400. So if I look at it, maximum will be 1, but that is not what the output says. The output says 2. So the way this guy has to be played is slightly different. So what we need to do here in this case will be like, start with 100 first. Okay. When you start with 100, so you gain 1 point, right? So when you gain a point, that is fine. So, but when you're playing for the power, you start from the back, because you'll gain more power, right? So if I play from the back, actually for the gaining the power, because 400 is the greatest one. So I will play with the bigger power. So I will gain more power in that case. So here what I will do is I will lose my point here to 0. Okay. And then I'll be gaining more power. So 100 plus 400 will be 500, right? So in that case, now if I start playing for the points again, so this is 200, right? So I can play this, make it to 300, but I gain 1 point here, right? So when I gain 1 point here, and then now I have this 300, then I can go and again gain 1 more point. So in this case, my point will be 2, right? And then I can return my output as 2. So the only trick here is actually when you want to gain points, you start from the lowest value, but if you want to gain power, you start from the largest value. So that is the only trick in this whole problem.
Yes, sir.
Okay.
Yes.
Yeah. So any questions on this problem statement before we start discussing the approaches?
So, I mean, can you play or whatever, even if you have a number of points 0?
No, you can play, but in that case, your power bag of tokens should have power which is lesser than your input power.
Okay.
Then only you can actually, first you have to gain points. That
Okay.
our objective is to gain more points.
Okay, got it.
I have one approach. Can I share?
Ankur, right?
Yes.
Okay. So anyone,
So
any questions, anything, any doubts on this?
So our tokens
Sorry?
are tokens sorted?
No, there's nothing written like that. If
We
you
have to
look
sort it.
at, huh?
We have to sort it first before.
No, I think in the conditions below it says token of I is okay. I think it just says like it is greater than 0, but it doesn't say it is sorted.
No, it doesn't say any sorting. Yeah, that is true. So yeah, that is one thing we'll have to always, remember or maybe discuss with the interviewer. But here it is not sorted. Yeah, in the example, always they do it like that, to confuse us. But here it shows it's sorted. But I think that is a very important thing to consider.
Sir, can you explain the last part, like how it get 2? I was trying to solve it, so I didn't understand.
Okay, so what you do is, when you are actually gaining points, you start from the lowest number, right?
Mm-hmm.
Because you have to always satisfy the power requirements, right? So the first 100 I had, and my power was 200. So I played with that. I gained 1 point, right? So I lost 2 power. So now my power is 100. But what I do is my power is 100, but I can actually gain more power if I start
By
from
losing a point, yeah.
So if I take the bigger one, so I gain more power, but I lose a point. So I started with the 400. So always when you want to gain power, you start from the larger value. And if you want to gain point, you start from the lower value. So that is the whole trick here.
I mean the last 2, how it got, like I don't understand the last.
So
the process I understand.
So yeah, see now in this 100, the first one, actually I gained 1 point, but I lost power, and now my current power is 100. So and then what I do is I lose my 0.1, but I will gain more power by adding 400 to, I'll get 500, right? So when I have 500 now, so I go for the second one, because I can't use the tokens which I've already used. So I'll go for the 200 one. So in that case, I will go with 500. So my current power will be 300, but I'll be gaining 1 point, right?
Yeah.
So now what is remaining? My power is 300, Okay.
Mm.
And I also have a bag of token, which is the last token, which is having power 300. So I can use that,
Yeah,
right?
I'll use my 1 point
Yeah.
and get
So,
400 again.
so no. I see this is 300 and now mine is this is 300, right?
Yeah.
So I will lose my power to 0. Okay.
Mm-hmm.
But I already have the 1 point earlier. So I'm gaining 1 more point and therefore it is 2 now.
Okay.
I'm adding that point, right? Because I don't
So
want to.
when it's big.
I'm sorry. So I will only decrease when I actually want to gain power. But I don't want to gain power in this case because my objective is to increase number of points. Correct. But that is the first thing what I look for, whether I can increase a point, So here I opted for increasing the point because my bag of token has a power 300, which is less than or equal to the power what I currently have. So I will go for that first, right? And therefore, actually the value becomes 2.
Yes, sir.
Okay. So, okay, Ankur wants to share. So, sorry, let Ankur go ahead with that. Right, Ankur?
Yes, yes.
Okay, go ahead. Let me check on the chat what people are saying.
Like what Santosh has said, I'm doing the same. I'm doing the same only. Like first I have to gain points, so I will start from here. Then that first I have to gain points, so I will start from here. And suppose like I can show you like suppose I have some initial power value we have 200. Then I have to gain points. Therefore, I'm starting from here. Then since I have got some points, suppose I got some say points equals to 1 after like getting this 100. Then I can buy some another power. So I am starting from here. That is 400. Why I'm taking 400? Because since the numbers after 200, after 100, it is lesser than 400. So I can use it to fight to make it 0, right?
Mm-hmm.
So that is the main intuition behind that. Why we are taking the last one, because I can use it to make this one at 0 to gain more points, right?
Yeah, in
So
future you get more points. Yeah, that's right.
therefore I'm taking greater value so that I can make it to 0. Because first to make it ensure that it will work, I make first sorting this array, right?
Mm-hmm. Mm-hmm.
So what I'm doing is that to apply this algorithm, I'm taking 2 pointers, that's L, and here I'm taking R.
Mm-hmm.
So first to gain points so that I can buy this 400. So to gain points, I'm first starting with L and decrementing the 200 with this A of I. That's A of I.
Mm-hmm.
Then what I'm doing it until my point is greater than the A of I. Suppose in this example it is up to here only, because after that I cannot fight this 200. Therefore I have to buy someone, because I've got some points now, so I can buy this 400. So I bought this 400 and incremented by P, and my coins got reduced, and I incremented my pointer to R, because now this is not no value for me, right?
Yeah, you can use always only a token once. Yeah, that is right.
Because I have not bought it, so it is not of any use to me. Therefore, I recommended my pointer to less my 1. Now, since I incremented my that after decrementing it got 500. Suppose now it got 500.
Mm-hmm.
Because after 200 got 200 minus 100, this 100. Then I incremented it is 400, so it is 500 now. P equal to 500. Now my L is at here.
Mm-hmm.
Now I can fight this 200,
Mm-hmm.
and it will consume my whole array, and I will do this until L is less than equal to R.
Mm-hmm.
This I will follow.
Okay. Yeah, before Ankur going ahead, someone is raised an hand. Ranveer. Ranveer, do
Yeah.
you want to say something?
I mean, the array is sorted. I mean, the given array is already sorted, or we
No,
have
we
to
have to
sort.
sort it. We have to sort it.
Okay, okay, that's good. I was thinking like if it's not sorted, then it would not work.
No, it is
Yeah,
not sorted.
if
It's not written there, so we don't assume it, right? So we have to
yeah, we
sort it.
have to sort it. Yeah, if
Yeah,
we sort it, then it will work.
yeah.
So
One
if it is
thing for this 200 plus 300, you are doing it together, Ankur, or like
no, actually I'm taking a for loop for I, and I'm every time checking that it is if I of I is greater than p or not. If it is greater than p, then I will only decrement this 200 for 500. So now after this, I have got 300. Still, it is greater than equal to a of I is greater than p of p is greater than equal to a of I. So I can decrement it. So then and then like this I'm moving in the array.
Okay, so left and right pointers. So whichever we need, we accordingly increment and decrement to gain more power, right? Like
Yes, yes.
coins.
Yeah,
Points,
more
points.
points. Yeah. So he's trying to use a two-pointer approach, but pointers will be starting from the opposite ends. Correct, Ankur?
Yes, yes, yes. Opposite ends. First beginning and other is from the end.
Okay.
So should I share my code? No.
Suppose suppose we have like 100, then 300 and 400.
300 and
Okay.
400.
Yeah.
Okay.
So let's say suppose the first pointer is right now pointing to the second 100. The first pointer.
Like I'm starting with it from initial only.
No,
Like
no, he's
suppose
saying that first move it to the second element, right?
Okay.
Yeah.
Okay.
So
Okay.
at that time, would you gonna pick 400 or you gonna pick 100?
That depends on the that depends on
Because
the
if you
current value
pick
of p.
400, you're gonna gain more power, right? But
No,
it
actually,
sounds like you still pick 100.
It all
no,
depends on what your input power is, right? So that is
yes, it
also
depends
a
on the
constraint which we need to consider, along with those two left and right pointers.
Yeah, but at this time we know that on the second pointer we have 400, right?
That's
So
correct.
if we pick 400 at this time, we're gonna gain more power. But why don't we do that?
We can do that also, but I think this will be a slightly efficient way of doing it, because in some cases, if we have the tokens differently, then actually that one won't work.
No, actually, I can explain it because
okay, go ahead.
I am first checking in the loop that if my current p is greater than this a of I, then only I will increment this L. If it is less than the a of I, then I will buy this, because for buying the particular power I should have some points. Therefore, I'm first iterating for first incrementing L. First, I am checking for the L, that is the left pointer. If I got some points, then only I can buy this.
Yeah, that is a
So it
condition
all
there. Yeah.
depends on. Therefore, it all depends on the P.
Yeah, but at when you point to the second 100, you have 1 point already, right?
Yeah.
You also still have 100 power left.
Yeah, so he's saying
you're right.
that is right. Yeah, then you can pick it up. Yeah, that's absolutely right.
You can pick it up, but I have to maximize the number of points therefore I'm taking 400, so that in future I may be safe, so that I can increment L up to maximum value, so that at once I can pick up maximum number of points. That is the main intention behind it.
Yeah, so he's trying to say that our goal is to maximize the points. Okay, so if we do it this way, we can actually try to gain power, but first we need to actually see if we can increase our points. And to increase our point, there are two things. What is the current value of the power remaining, and what is the current number in your tokens? So based on those 2-3 conditions, actually you'll have to play with it or decide the best and optimum solution.
It's more of like a investment. Like you are going one step backward just to gain 2 steps more. It's more like that.
Right. Yep, almost similar.
So should
Yeah,
I share?
go ahead. Yeah.
Okay. Share screen. Now it is visible.
Yeah, it is visible. Yeah.
Okay. So first, what I is doing is that for our condition, that for our algorithm to work, it should array should be sorted. So I sorted this array initially. I took two pointers, that is L and R, that is pointing at the initial point, and the ones and another pointing at the end location. And what I said initially, that I'm first checking that my current power is greater than or equal to tokens of L. So it means that I can consume this token of L. So and if I'm consuming it, so I can increment my points, and I'm subsequently decreasing my current power by tokens of L and incrementing L plus L also in the array. And this is my breaking condition. If both pointers meet, it means that I have consumed the whole array. And if suppose if my points become 0 suddenly, then also I cannot buy the tokens that are pointer. So that condition also I have to break there. So then I will increment since I have some points. Suppose if my points is greater than or equal to 0, since I have some points, so I can buy that tokens at the last position, that is R. So I'm buying that, and points will be decremented, and subsequently decreasing the pointer that is at the last location to the n minus 2. This is how.
Excuse me, Ankur.
Okay.
Actually, you have pretty much done the same thing like the other person was asking when he gave that example of 100 and that thing. What you have done in from line 11 to 15, you have basically what you have done. You have in the started taken those first 200s.
Okay. Yes. Yeah.
Yeah. So that's the mistake you have done there. Like it won't be that right answer then. You have to.
Sorry, I also think that that's because you don't keep the max so far. So at some point you're gonna decrement the point, right?
Yeah.
So you might not get the right result. You have to keep the max so far, after the second while loop.
No, actually, we have to. We could let's say it like that. What Sir explained, Santosh Sir explained, like at the time of earning 1 point, we should go from the starting, that the least available. We have to use that power in gaining 1 point, and in order to gain more power, we should use the last greatest, you could say the greatest energy available.
Like that. That's what I'm doing.
What you are doing here, you are first taking all the points which you could take using that power. You are basically doing that, but that won't be the case, right? You are basically you are using all the power at the initial stage only. Then what will happen, you could say, like if we take the example of that 100 thing, it'll be like
I think it was 300, and I think Ankur, it might be in your notes, right? Okay.
But this P greater than equal to token cell is checking that thing, right? Like if my power is not.
I think this is a different way of implementation, but it is almost the same, I would say. But it's
no, I think it is correct. It is correct because in the while loop we are already checking P greater than equal to tokens of L. So here we are checking the power also, and if it is like decreasing, then we are out of the loop, and then using my right pointer to gain power, right, Ankur?
Yes, that's the same.
And he's actually preserving the points to the last one, and then he's just returning it. But as Leon said, we could also do one thing instead of doing this approach. What Leon's approach was, we need to actually have some max so far, some count, something like that, and keep on updating that also. So in that case, we don't have to go through this while loop, you know. So that
Okay.
so there are two different approaches. I think this approach is also correct, not an issue.
Anchor, can you submit this one?
What are you saying?
Can you submit it? Yeah, sure. I think he might have done that earlier.
Okay, I can show you.
Oh yeah, yeah. But line 9, number 9. Actually, you'll have to comment in line number 9 what you just wrote, right?
Okay.
Yeah. He's just showing that if you can submit now, yeah, it might work. Yeah. Yeah. So the way he is slightly doing it differently, but yeah. But I was trying to explain it the way I understood because I was just going through that input, and it really didn't make sense to me for the third example how they are getting 2 points. So yeah, but that approach also works. But the second approach, what I was discussing, which we can have 2 left and right pointers, right? You know, that is the generic algorithm, and therefore it fits in my mind. So I always remember that very well, and that is the reason I will use that always. So, but this is also a different way of doing it. Yeah.
Actually, greedy approach. Someone sees initially it seems like it is wrong because intuition doesn't come in mind in that very initial stage. It takes time to come intuition. So in greedy things like that goes like that.
Yeah, yeah. So it's a different way of thinking every time. Yeah, everyone will have different approaches, that for sure. Yeah. No problem.
What would be the runtime complexity of this one?
Okay, yeah. So I would say still O of n, right?
O of n, because I'm considering of all the array elements only once. Because
no, it will be O of log n log n, because you're sorting.
Sorting. Sorry.
Yeah.
Okay, so my question is, could you do better than that?
Yeah, that's a good question.
So my thinking is, you know, maybe we could do better than that, and we could do it in big O of n by, you know, maybe we need extra space. So we could have 2 heap, you know, one's min heap and one is max heap. You know, in that case, when we remove one element, it only log n, right?
Maybe you have to remove n log n. Yeah, that's correct. So how do you go that?
Heap also will take n log n, like time.
No, I think it only log n, right? Because you put initialize the heap with all the element initially.
Heap will take n log k.
N log k, yes.
Yeah, but let's understand what he has to say. Yeah.
Yeah, initialize the heap. I think it's only n. You know, if we look at the, I think Roger would talk about it, and we can look it up. And also, you know, take one element from the heap is log n. So it's not like, yeah, it shouldn't be, you know, so total will be log n.
No,
right?
I think so. All heap operations will take n log k space because you have to heapify the items when you insert.
Only log k, log n. If you have a heap, you take one element, only take log n.
Yeah. So
right?
For a single operation like insert or you know, do anything, so it will take at least log k or log n, whatever you say. But if you have to do it for each and every element, which are n elements, then it will be n log n or n log. Yeah. So something like
yeah,
that.
that's why you initialize the heap with all the elements.
Okay. So I'm not. Do you want to share your approach or maybe discuss on a whiteboard?
Yeah, yeah, I can.
Please.
I don't have it, but you know, I can share the link. You know, why it take only you know, maximum log n.
Okay, no problem. But if you want, you can actually discuss that and explain it on a whiteboard also, if you're fine with that.
Yeah, it actually it takes log n. Yes, sir.
Yeah. So let's actually understand what he has to say. So.
No, I cannot share right now. Sorry.
Okay, no problem. Go ahead.
So you said, would you be adding all the elements into the heap?
I think he's sharing his link, so let's go through that. What he has to say.
Actually, like storing in the heap also will like another thing we are checking the space also, and complexity also is taking the log n, but we have to store that also in the heap. So building of the tree also heap tree also will take n log n. No?
Yeah, he's saying that space is more, but time might be slightly lesser than what we are working on. So
okay,
let's have a look at that. Yeah. So you're saying you shared it in the chat, something like that, Leon?
Yeah, I'm share.
Ronnie
keep going. Yeah, I will share later. Yeah.
Okay, no problem. So Ronnie said something in the chat saying, does this work for example too? So Ronnie, are you saying something for this one? The same same bag of tokens, right? I missed your chat. Sorry about that. I think it's not online now. Okay, no problem. So we actually solved that, right? Yeah, Ankur. It should work for example too.
It is passing now.
Yeah, it should work. Yeah, that's right. Maybe sometimes we'll have to show it how we'll have to walk through the examples. That is what people expect, so it's more clear, right? Some of the problems are very complex to understand.
Sir,
Sorry, go ahead. Who is this?
yeah, I was thinking of a different approach, and I'm like in the middle of, like, I don't think it's gonna work or not, but I think you should check this out. Can I explain?
Sure. Okay. You are Ranveer, right?
Yeah.
Okay, go ahead, Ranveer.
So what if we loop through each element in the array? Okay. So, and we created a variable like rem or something that will like t minus each element. And then if the rem is like greater than 200, we will count, increment our count. And if it's not, and the count is greater than 1 or equal to 1, we will like remaining will be we will add the like next array and subtract it, so that it will like greater than 0. Rem will be greater than 0, so we'll have another point. I don't think I can explain it. Can I just show you how?
Yeah, sure, no problem. But if you want, you can explain on a whiteboard. You can share your screen in the Zoom.
I'm actually on my phone, so.
Okay. So how do you want to go?
Okay, let me just take a picture or something. Does it? Okay, I can use my front camera. How can I switch? Okay.
Actually, yeah, okay. So that is blurry. Yeah. Sorry, we're not able to see that. Okay, no problem. Then, yeah, Ranveer, I don't think so. It's very clear to me. Yeah. So maybe, yeah, you can go ahead and just talk on the now you're on this phone. Yeah, that should be fine.
Santosh has his on the computer, so he can share some say like a sketchboard or something to explain the algo, and share the sketchboard link here in the chat so that we can access.
Yeah, Ranveer, did you hear this? What Praveen is saying?
So you can open that link and share on the screen so everybody can see that through.
So he has shared it in the chat? No.
In the chat, someone
it is
actually,
Leon.
that's
Yeah,
Leon.
Leon.
Yeah.
Ranveer, sorry, we are not able to see your screen very clearly. So.
Oh, okay.
Do you want to talk about that?
No. I just share the link.
Okay. So this is Leon saying, okay, no problem. So Leon saying that he has shared some links from the Geek of Geeks, the time complexity of building a heap and the time complexity. Oh, that is fine. We are good with that, Leon. What you say is correct. Yeah, that's not a problem. But I thought you have a solution for this problem which can be solved in O of n or something much better than n log n.
Oh no, I don't have it.
Okay,
Just my idea. Sorry.
No problem. Yeah, that might be okay. So I think we don't have anything for now. And if Ranveer, if you have something to share, you can actually post it in the Discord channel, and we can actually take it from there. Okay?
Yeah.
Okay.
Thanks.
No problem. Thank you. So okay, so Ankur shared his this one. I'll quickly share mine. It's almost similar what he has shared. Okay,
Yeah.
so this is someone did this. Okay. It is almost the same, but I slightly did it in a different way. And this is the way I did. So I'm setting 2 pointers. First, I do the same thing, sort the whole tokens array, the input array, and then I'm using left and right pointer. And I'm actually going through this 2-pointer approach, the opposite ones. And then first, I'm giving preference for the points. So I look for this condition. If my tokens are lesser than or equal to my input power, then I go for that, increment my points. And then as Leon was saying, can put something condition to actually see what max so far is. And I'm doing that over here. Okay, and keep increasing my points. And if I see if I have anything greater than, the points are greater than 0, but the only condition will be my tokens left will always be given preference, right? So if
I was trying to do something similar like this, but I didn't sort the array.
Oh yeah, if you sort it, then it will work. If you don't sort it, then it doesn't work. Yeah, that is right.
I will try to solve it and send a link or something. Solution.
Yeah, please.
Okay.
Yeah. If you just sort it, then actually things make easier, Or else you'll always get, for the third example, you'll always get input answer as 1. Your output will be always 1.
Yeah.
If you sorted, yeah. Because then this is the preference, right? We always go through this one. Then it won't work. Yeah. So so then in this case, if I have more points and my current token has lesser, it doesn't satisfy this condition where it is greater than the power. So I can't do, so I have to come here and gain more power in order to get more points, right? And then if I'm in this condition where neither of my points, I have points or my tokens are also greater than my input power, so I just break it here. That's the only condition I break, and at the end I return this answer. Okay, so this was very similar to what Ankur said, but Ankur was slightly doing in a different way. But that also is a correct one, and this is another approach to think about. Okay, so if everything is okay, can we move to the next one?
Yes, sir.
Okay, no problem. Let's go on. So this is the shortest subarray with some at least k. It is a hard problem, and what it says that we need to return the length of the shortest non-empty contiguous subarray. So we are given an array of integers, and so we just have to another input called k. We have to look in if we can find any value, which is like if I have an input like 2, if I take the example 3, 2 minus 1 and 2, and if my k value is equal to 3, so I keep on adding all of these, like 2 minus 1 will be 1 and 1 plus 2 will be 3, right? So I satisfy this condition. So I can actually return the length of this contiguous subarray, which is 3, right? So this is the input and the problem statement. But the other notes say that the input can be very big, like a 50,000, and also the value of elements can be negative numbers from 10 raised to 5 negative and to positive 10 raised to 5. So that is also a big number. If you want to add it, we might have to take care, maybe, may not, it might overflow. Not thought about that. But also the k, what they say, is also used, like 10 raised to 9. Okay.
Okay.
So any doubts about this, need for clarification of the problem statement? The problem statement is very clear, right? It's very simple. We have to just find the sum of a contiguous subarray, and it should be equal to k or greater than k. So, but we need to return the, what you say, the shortest one. Means if you have many numbers, many lengths like that, we need to find the shortest length of that contiguous subarray, and that we have to return. And if you don't find it, just return -1.
Okay. So I think so. This can be solved with a sliding window technique. So you start with a window saying that the start and the end of your range is at the 0th index, and then you start consuming the elements on the right hand side. Once you reach the sum of k, and as long as you can satisfy that sum is greater than or equal to k, you start decreasing the size of the range from the left hand side, and while you do that, you keep record of the shortest window you have seen so far.
So are you saying the two-pointer approach both start from the opposite ends, or both start from the left side?
Both start from the left end. I don't know if this works. I'll have to run a few examples and see. But
yeah, no problem. We can walk through, no issues.
Yeah. So you keep a pointer on the, let's think of the example on line 8. You keep a pointer on 2.
Okay.
And you keep a pointer on 2, like there itself.
The first pointer.
Initialize, yeah.
Okay, second pointer here.
Okay. And so you move the second pointer.
Okay.
While moving the second pointer, you keep adding the sum.
Okay.
So now the sum becomes 2 minus 1. It is 1. It is still not 3. So you increase it further. Now this becomes 4 minus 1, 3. So this is actually at least equal to 3. And now you start decreasing the pointer from the left hand side.
Increasing,
yeah. When you decrease, the sum decreases, right? So the sum decreases, you move out of the loop because you cannot satisfy the constraint. And then you record the length you have seen so far. That would be previous length.
Okay. So the previous one will be 3, and then you will return that also. Okay.
Yeah.
That may work, but if
but the only thing that I have is it says with sum at least k. So
yeah. So in some cases it might be more than k, right? So if you the one thing what I found was, because that's, if I have an input like this, 99, 48, 99, 37, and this is an example, actually a test case which I got when I was solving it. And I was actually thinking like, okay, because I didn't read my this problem statement very clearly. I thought it should be equal to k, and I was just working on that. Okay. So and if I have a k as 40, right?
Okay.
So then this one output actually, it said that my output will be 2, So and then I was not able to actually understand why it was saying that. So output, it is correct, right? Output should be 2.
48 and 99. 48.
Just a minute, I have something to do. You guys keep on discussing.
Okay, 48 plus 99. think so. This must work.
Hmm?
I
This,
think that
this will work in this case if you have a k equals, if it is greater than or equal to k, right? So
yeah.
that should work. Yeah. But there are some cases which this might, the sliding, this is a good one to start with, I would say. But if you have something, okay, let me see if I have another test case, something like this, So if I have 2 minus 1, then you have 2, and then I have 4, and then 6, 1, 1, minus 5, and then 7, something like that, right? So if I do this, and my k will be 9. Okay, k is equal to 9. Okay, so in this case, what will be my condition here? I think it should be 2, right? So will this work? Can we just quickly run through the way the approach you described?
Yeah, I'm coding it up.
Okay. So the way I saw, because I was also working on this two-pointer approach, but the way they say you need to actually find a prefix sum, and then if you find a prefix sum, you should be able to do it. But for prefix sum, just using a prefix sum won't work. Then you'll have to use some trick to actually get this. So I would say it looks the two-pointer approach, but it's still sort of a two-pointer approach. But you'll have to use an additional data structure in order to do this, or else you won't pass in all the test cases what they are saying.
Oh, okay.
Yeah,
okay.
so I don't have a test case in my mind, but I think this test case might be something which we have, if we walk through, it might be possible that we might not be able to get this results. But yeah, I may be wrong, yeah. But there are some test case for that you need to use an additional data structure, then only it works. And the way they, when I was going through all these and struggling to actually implement using the two-pointer approach, then I just started reading the discussions forum, and then I found you need to use an additional data structure like a monotone queue, the way we were actually discussing earlier in some problems, monotonic stack. So we'll have to use something like a monotone queue, then only it works. Something like that. So what they say, if I take this example, I'll just quickly show you guys how this monotone queue actually. So if I have
so do we have any example where it will fail with the two-pointer approach?
Well, I'll have to run something and then get it. Okay, let me check then. Yeah, two-pointer approach surely doesn't pass all the test cases. That is okay. Give me a minute. I can find out. Maybe I think the first test case only it doesn't work. It doesn't go ahead with that or something. Okay.
It works with the first case.
It passes?
No, it does not.
Okay, let me see which one doesn't pass. But there is something, yeah. Okay, this test case, I'll show you what it says. When you have 17, you are able to see my screen, right? The whiteboard?
Yeah.
17, 85, 93, minus 45, okay, and minus 21. And if your K is 150. So that doesn't pass because what it says, my output when actually run through this two-pointer approach, it gives an output 3, but the expected is 2. So, okay, so that is what actually when I was working on, I have one implementation which does this two-pointer approach. So then that doesn't work. Maybe I didn't use it properly. I don't know. So
I mean, looks like, I mean, it should be 2, yeah.
Yeah. Maybe my implementation was not correct. So if anyone has a two-pointer approach, a working one, or maybe you want to discuss that, that should be fine. We can walk through with some example and see if it works.
Which two elements make it become 150?
85 and 93.
Yeah.
85 and 93? That's
Yeah.
not 150.
It should be
5 and
equal
3
to or
is
more
8.
than.
So it's the requirement is that it should be, yeah, minimum should be 150.
Yeah. It should be greater than or equal to. Yeah.
You
So
can try this counter example. 2, I was just trying to jot it. 2, 1, minus 1, 4.
And the sum is?
So let's say sum is 4.
So could you repeat your example again, please?
Try 2, 1, minus 1, 4.
And sum is 4.
Sum is 4.
1 minus 1, 4. Okay.
Sum is 4.
Okay.
It should be 1, right? Answer should be 1.
Right.
Okay. Okay.
So if you actually implement through using a 2-pointer approach, you know, if you try to match some test cases, it fails on other test cases, something like that. You know, that is what I think. Yeah.
I think so. There's a way around here. 1 second.
So are you coding something?
Oh yeah.
So you can share it on. We can actually all look through it. You know.
Okay. 1 second.
Yeah.
With the latest example, 2-pointer approach should work, right? It should return only 1.
No, but the thing is, there are other elements within the array. Like in the last example, you see he has added 4. So 4, just one single element of 4 would result in 4. So that's just a single element that would result in the answer. So
yeah, but when you get to 4, let's say your sum at that time gonna be 6, right? Because 6 is greater than k, so you keep moving the first pointer.
No,
right?
So if you try to satisfy, even if you put those things as a special case, you will break some other test cases. You know. So it's very tricky actually, the implementation. Yeah.
So what I'm thinking of is each time we reach this sum, where we reach this line 13, we construct a list of all the numbers, because those numbers can produce actually produce sum of 4. So with sum, so then once we loop through this window here. This window satisfies a result, right? We loop through this window and compare the pairs, compare the elements in the pairs such that the sum is greater than or equal to 4. So like in first case, when the window is, I think so this might work. Okay. So in the, 1 second.
Sure. So which one you are trying to solve? The 2 minus 1, 2, 4?
Yeah, 2 minus 1, 2, 4.
So then why don't we run it? Because you already have the test case, right?
Yeah, I have the test case, but here the code is not. Let me just read this.
Oh, no problem. Go ahead. Yeah.
So int a, then this can be array, and this is my start of my window, and this is my end of my window, and then I need to populate the results. I can have a list of integer and list of integers, where I'll be populating all the results one by one. I can say nums, or I can say
yeah, nums should be fine, right?
Nums should be fine. Okay. So then what I do is I loop through this window. First I need to create an integer list. Say result is into new array list, and then I could loop through this window for int I is equal to start, or I is equal to end, I is greater than or equal to start, I minus minus, I come back, and now I could add all this into my result, add 0 a of I, right? And now I could add nums dot add new array list. I don't know if this is possible. I need to add the result into this nums list. So I pass new array list, and can I pass result here? No.
I don't know what the syntax for Java. If
Yeah.
anyone can help him.
Yeah, 1 second. This should be, yeah, this will figure out. 1 second. This should be new array list of, I think this must be result. I don't know if this will work or not. Let's just check it out.
No issues.
Now, this list and list of integer, I need to keep track of this guy. List and list of integer. Let's say result is equal to new array list, and then I build up the result list here. Now let me just see if this works. I will have to print out the result here. Okay, and now this would give me, it should be like I should do some additional processing here. I should send the sum here. I should send the sum here. So if I send the sum, that would be k. And now while I'm populating this list, like while I'm adding into this list, I'll have to see if the constraint is met, if the sum is greater than or equal to 4.
Oh, so you are actually okay. So you'll have to check that and then okay.
Yeah.
So then make that modification before you run it.
So yeah, before that I'll have to print this result list and see if this is being populated correctly.
Result plus.
Result list.
You are having something with the result plus.
Okay. Yeah, so that was wrong. Yeah. Result. So the sum is satisfied. Now let me populate the list and build results of A, K, not start, it should be WS, W end, and this should be result list. Okay, so this is not needed. For now I could just return -1 just for
no, I'm sorry. Maybe you keep it like this.
Proofing.
I'll do that later. Yeah.
Okay, so now now we see we get all the list of numbers, like all the combinations here. See, 4, 2, 4, -1, 2, 4. Can anybody see? Can everyone see?
Yeah, that is correct.
So now we got all the combinations, but I have to make sure that there are duplicates here. That I'll have to fix. But yeah, now I got all the combinations. I'll go through these combinations. Remember the least size of the list, and then return that. I think so. This must work. It works for this case. I don't know if it fails for any other case.
Okay, so you are saying you can just look for the minimum value in the result, right? And then just return it.
Yeah.
So if you do that, then it should at least pass this test case, right?
Yeah.
Can you do that so we can actually look for the other test cases if they work?
Yeah. Okay. So this is result. Now I have my result list. This result will be holding the max value right now. And now what I do is I loop through this list for list of integer nums. I can't say numbers, or I can say yeah, I can say nums itself. And for list of in result list, result list if nums,
I don't know something.
If nums dot size is less than result, then my result is equal to nums dot size. And now I have the minimum size always. And now I should just loop through this list again for list of integer nums in. There could be a better way to do this, but yeah.
Yeah, no problem. So we'll at least find out how we can get the results, you know.
If nums dot size is equal to result, then return. So we should return the size, right? Return.
Right. So we just have to return
result.
integer. So it should be the size. Yeah, that's correct.
And so, yeah, so this returns fine for first cases. So size is 1 and size is 1. Yeah, we'll have to think of additional test cases now.
Yeah, just comment out those print lines. Yeah. Then,
okay, then I can run the test here. Let's see.
Let's see if it works.
I think so. This might fail out. Yeah. Okay. So it fails. So it fails for the.
So that is what actually, you know, if we focus on one thing, so we might fail on some other test case.
Yeah. Okay.
So maybe I'm not saying that it might not be possible, but with some extra space, we might have to take care of something, and then it might work. Yeah. But when I was going through, I found, you know, this to be the two-pointer approach always a tricky, you know, to use for even this simple one.
1 second, but for 2, yeah.
So
yeah,
what I'm trying to say
okay. I did not do this. I need to sum up the list here.
Okay, go ahead.
Sum should be greater than or equal to, no, I should minimize the sum. No. Now I have the sum greater than or equal to k. When I go to -1, 2, this is 4, but this sum is not 4.
Yeah, Rishabh, maybe, you know, if you take some time, you might be even able to crack this. Not an issue. Yeah, I would say. I'm sorry, actually, I'm pressurizing you here.
Yeah, no problem.
Yeah. You take your own time, and if you get some solution, yeah, you can post in the chat. That should be okay. That's not a problem. That's what I'm saying. We might have definitely more optimal way of doing it, and the way what you are doing might be the best way to do it. Yeah.
Yes, I think so. The problem is the way I'm populating it here. I just know this one way of populating to get all the combinations. If I don't do this result.add 0, then I'll miss out 4.
Okay.
So I don't want to miss out 4.
Right.
Okay, so then I need to again calculate the sum. I'm doing double work here now.
Yeah. No problem. So maybe you keep on working this one. Okay. I'll quickly share the way what I have. And then if you are able to again resolve this, then we can again come back. Okay.
Okay. Yeah, sure.
Yeah, no problem. Can you just stop sharing it?
Okay. Yeah.
And in the meantime, when you come with your working solution, just ping me and then we'll go for it. Okay.
Okay.
Yeah. Thank you. So the way, you know, it is implemented, what they say, like if I take an example, well, I was talking about this one, right? This came up. Okay. So what is being suggested? I can't do everything. So to use a monotonic queue, okay, and so use a monotonic queue, and yeah, that's all. So that should work. And monotonic queue is nothing but you have a queue, maybe a double-ended queue, but before that you actually find a prefix sum. So if I take an example of maybe I'll take the bigger example, yeah. So something like 2, -1, then you have 2, and then you have 4, and then 6, okay, and then you have this 1, okay, 1. This is my input, and my k will be 9 in this case. So this is my input. So what I will do first is find a prefix sum. Okay, this is a prefix sum. So the prefix sum, what I will find is I start with the first element as 0. Okay, then I go for the second will be 2, and then this will be 1, and then will be 3, right? And then will be 7, and then will be 13, and then 14, and something like 15, right? So, and if I see these are my indexes, like for this prefix sum array, 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so then if I do monotonic queue way, so if this is my double-ended queue, which is a DQ, so what I do is first I insert my prefix sum element, the first 0 over here, okay, and then I iterate through this prefix sum array each and every time. So now I'm in this index 1. So I look for what is the value of at that position. If it is yeah. So I want to keep a monotonic queue and in an increasing order. So if I have 2, I'll just put it 2 because 2 is greater than 0, right? So, but when I'm putting 2, okay, so I put this, but before that, I would actually compare the 2 with the first element of my queue. And if I see if it satisfies the k condition, so 2 minus 0, it is definitely not greater than or equal to 9. So I don't do anything. I just put 2, and that's all. Then I come for 1. So now when I move to this index here, okay, so 1 actually is lesser than this 2. So I just remove this 2, okay. I just remove this 2 in this, and then because I just pop this out, okay, from the back, and then I look for 1. If my 1 actually is, now it is greater than 0, so I can't do anything. And then I see if 1 minus 0, which is the first element of the queue, if they are satisfying my k condition. If it is not, then I just again put this in the queue as 1, right? So I keep doing this for the 3 also, because this also doesn't satisfy. But then when I come for 7, okay, so at that time also it doesn't satisfy, okay. So then I come for 13. So 13, now actually if I look for this 13 minus 0, it will satisfy this condition k, right? So 13 minus 0 is definitely greater than k or 9. So then I can say, okay, I have an element over here which satisfy my condition, and then I can take the difference from this index, which is 5, to the 0th index, which is 0. So, and then I say my answer will be, so something like 5 minus 0 will be 5. But then when I find this, okay, I see, okay, there is something which I can again minimize. So then I start contracting my queue. So what I do is first remove the 0, because I've already seen the answer is 5. So I try to find if I can find a minimized version of it, the minimum length. Then I now come to this queue index, which is 1. So 1 is the index of 1 is actually 2 here in this case. So 5 minus 2 will be 3, right? So this is definitely lesser than my answer. And also 13 minus 1 is greater than or equal to 9. So this still satisfies. So my answer from 5 minus 2 will be 3. So I can say my answer, update it to 3, right? So then what I do, I again pop this element from front. That is the reason I'm using DQ. So I can pop and push from front as well as from back, okay? And then when I come here, I see, okay, this is fine. Then again, I come here, okay, now try to compare 13 minus 3. Is it still satisfying the condition? Yeah, it is satisfied, right? So it is still greater than or equal to 9. So then what I do is I take 5 minus this element at index 3. So 5 minus 3, my answer will be 2 now, right, in this case. So now it is 2. Okay, so then I again pop front this 3 element, and now if I try to compare with the 13 and 7, so if they are, it's not actually satisfying this K condition, and then I stop here, right? And then even if I go ahead with this monotone Q, right? So I won't be able to get a really optimum solution of 2. So that is the reason I found, using this prefix as well as a monotone Q actually works well, and it passes most of the test cases. But I think what
But
Rishabh
we
is
cannot.
actually.
Excuse me, sir.
Yeah, go ahead.
Sir, like how are we ensuring that, like in this case, we got the answer as 2, right? But what it can be possible, right? Like in the upcoming positions, or in the further part of this array, we could have an answer which could be 2, right? Like how are we ensuring that this answer 2 is the right answer? Like
Well,
we
well,
haven't seen the
so
we
if
haven't
you,
seen the further part of the array, rest part of the array. It could be possible, like there could be a single element which is equal to 9, right?
absolutely, yeah. So therefore, I'm saying you need to continue till the end. Absolutely. So you don't
Okay,
have to
okay, okay.
stop. But I know for this input, because I actually evaluated that earlier. So I know this is the minimum one, and we can't go more than that. But if you look also here, also it is 6, 4, right? You cannot go more than that, right? So this is the only 2 elements what we have in our case. So, but yeah, what you rightly say is we'll have to complete the whole monotone cube, the complete thing, and then only we can actually pass out our output. So yeah, it is quite possible. In the way I think Jagrut given one example, right? 2 minus 1, 2, and 4, and then he said if k is equal to 4. So how? So in that case, it will be the last element. So you will get an optimum answer only if you reach the end of the queue. Yeah,
So,
we'll
but
have to
then
do it.
how we will proceed now? Uh, like after this, how will we proceed?
So
Like
you you
we have pretty much covered this much part of the array, which is equal to, which is less than this 13 parts. So now if we go by logic, then we have to discard pretty much this part of this array, and we have to now start from 14, right?
yeah, okay. See, if I take an example here, 9, okay.
Yes,
So
sir.
what my output will be 23, correct? Okay. So
Yes, sir.
now when I finish 13, okay, for this 9, it was fine, right? So I cannot do anything more. So I put 13 here, and then move ahead. Okay. So if I do that, then I come for 14, which is element over here. So what I
And we
do,
would do the same.
yeah. So if I put 14 here, and if you see 14 minus 7 is not greater than or equal to 9, so I just put 14 and then continue. Okay. So I can't do anything more. So then I come to 15 in this case. The same thing I do, right? But now when I'm on 23rd, right? So I start with the whole thing again. So now 23rd, this is 7, this will be 8, right? If I'm correct, it is 0, 1,
Okay.
2, 3, 4, 5, 6, 7, 8, right? So now 8 and my 7 is 4. 8 minus 4 will be 4. It is still greater than this answer value of 2, right? So I just ignore it and just remove 7 from here, okay? So then I come from 23 and 13. So it is 10, correct? 24, 23 and 13, it is 10. And then actually I do that. Okay, 1 minute. What I did here is 24, right? This should be 24. I'm sorry. Okay. So 24 and 13, it is 11, right? So it is still okay. But then I look for 13 is 5. 8 minus 5 is still 3. So this is still better. This answer, my 2, is still better. Then I discard this 13. So 24 minus 14 is 10, right? So this is okay. So 8 minus 6 will be 2 still. So this is good. Okay. So then I discard 14 also. Then I come here 15, correct? So 15 minus 24 is 9. Still it satisfies, right? So in this case, what I have is
Yes,
8 minus 7, right? So which is equal to 1. Then I update my answer to 1.
yes, sir. Yes, sir. Got it.
Yeah, yeah. So then it actually it works. So yeah, but it is you use more data structures, and therefore it is more implementation, and also it's not a very intuitive way of actually getting to this solution. That is at least what I found. But yeah, but
Yeah,
this
it's a
is the way
very,
it is.
yeah, it's a very neat problem actually. Yeah,
Yeah, because
people
you
will
know,
get to, yeah,
whenever this problem comes in, when find a maximum subarray of contiguous, yeah, it is very tricky. But most of the times, our two-pointer approach works. But always give a try for a prefix sum also. You might find a very optimal solution. That is
yeah.
what I found. You know.
So this solution is presented by a guy. He's actually 10-year expert.
Okay.
Yeah.
Yeah, maybe. Yeah. Therefore, those
Hey,
things work. You know.
Santos,
Yes. Yeah, Ivan.
what is the intuition for using the monotonic cue?
Yeah, he doesn't explain very well. This guy who wrote a solution, he's written many solution. Yeah, he just comes up with solutions out of thin air, but he does not provide a clear
Is it
explanation.
Awise, right? Awise,
Yeah,
or what?
Alex, yeah.
Alex Wise, yeah, yeah. But actually, we had a similar discussion earlier. You know, when Roger gave us some presentation on monotonic stack. Okay, but instead of stack now, this is Q over here. So it is slightly similar. I think Leon, you were there in those sessions, right? So
Yeah, right. But I know the intuition for stack, not the
yeah.
queue. This is
Yeah, this is also new for me, but I found that very interesting and it works most of the time. Because if you just have a prefix sum, okay, and then use a two-pointer approach also, you're not able to pass all the test cases. That is what I found, you know. So then you have to use a queue. And even if you look at this one, the problem description, and when they say what the related topics are, you know, so they always say binary search and queue.
No, yeah. So sometimes these related topics are not, they are misguided. Yeah. Sometimes
But if you look at here, Q is seems to be very odd, right?
Yeah.
Yeah, but then sometimes you need to focus on why they are saying that also. It might give a clue.
Yeah. So what makes this problem really tricky is it can have negative numbers. So in case I got the solution working for almost 70 cases, it fails on the 71st case.
Okay.
When you have negative numbers, I can show you the example that is failing.
Okay. Yeah, no problem. Yeah, we'll go through that. Yeah, sure. That would be great thing to look. But I'll just quickly show you how this has been implemented, and then
yeah.
So the way actually he does, you know, here we actually do a prefix sum, and the simple one. Okay, that is a straightforward one. But then we use a queue over here, and then this is the way what is doing. So you go for the prefix sum, you look for whatever the current index, and you see at the top, at the back side of the queue, if it is less than or equal to, then you keep on popping it. Okay. Or else if you are not able to pop it, means that your current prefix sum has to be bigger than the top of your, I mean, the last element of your queue. Okay. Till that time you keep on popping. So you are actually trying to maintain a monotone queue, which is increasing order. So that is what actually it does over here. And when you find that, when you are there, then you start actually finding your max so far over here. So actually this is the min so far. And then you keep on updating your value the way we are doing, right? We are decreasing the one from the front of that monotonic queue. And then we are just popping it out. Okay. And then at the end, if nothing works, we just have to put whatever the current prefix value is inside it. Right. So this is clear, right?
Yes,
this
sir.
implementation looks very simple also. Yeah, but it's not an intuitive one at all, I would say.
Yeah, I would think so. This question is, I think so. This is out of bounds. Yeah, prefix sums and other things are out of bounds. I feel in the interviewer, like how can you come up with all this code in the interview?
yeah, but you are doing it right, so you are almost there. Yeah, so
But
maybe you never know. And see, it's such hard problems. They don't expect you to completely do it, but at least you have some solution, you know, to some extent. I think that should be will go good in your favor, you know. That is what I think. Maybe Yeah. Let's see your solution. Okay, go ahead.
So in that case, I think so my solution might work if there are no negative numbers. So it's failing for this case, minus 28, 20. So this numbers, right? So what happens in this case is the sliding window just goes on increasing. It goes on increasing, and then it reaches the end of the array and it returns empty array.
Oh, okay.
But what happens? But there are actually three numbers that can be added up. 81 minus 20 and 28. If you add them, you would get exactly 89.
Right.
So sliding window misses that, misses those numbers.
Yeah.
That is why it fails, because there are negative numbers, I feel. Yeah. Because there are negative numbers, what he does is he keeps a prefix sum, and then he's doing some internal magic with them. Yeah.
Yeah, maybe you'll have to consider some special cases somewhere, and then you might be able to even find out something. Yeah. So that is what I say, like the sliding window looks easy, but it's not always so easy. Yeah. Oh, yeah, that's very great, 70, almost 80% of the test is you have passed, right?
Yeah. It's very tricky, and yeah.
I think the problem with the sliding window is that it's kind of good in the sense like it'll keep going until you find a solution, and then once you have that solution, you will increment the star pointer to find a better solution.
Yes.
However, the problem here is if you cannot find that like solution in the first place, like if you have a negative number, then it takes a dip. Then you will never find a good solution.
Yes.
And then, so that's the problem here.
Yeah. Makes sense. Yes. That's what I was trying to convey. Yeah. You're right.
Yeah. So in some cases, we'll have to do some more, something different,
I think so. This question is out of bounds. Yeah. Only few companies ask this question.
Yeah, but it's good to know the way they are doing it, right? So, anyway, good try, Rishabh. Yeah. Okay. So, do we have anything more, or we call it over day today? Yeah. I think we have done with all the problem solving, and see you all guys tomorrow. Okay.
So where are the problems actually posted?
They are posted in the Discord, so they might have been posted already now. By now.
Yeah. It has been received.
Which channel?
The Discord channel.
Lead code. Okay, lead code practice.
Lead code practice. Yeah, sorry. Yeah. Okay, then thank you. Thank you, everyone.
Guys.
Thank
Thanks,
you.
Santosh.
Thank you, Praveen. Thank you. Yeah.
Thanks.